Hey guys, how's it going? In this video we're going to go over section 1, i.e. the multiple choice questions from the 2017 SQA National 5 Physics exam paper. Now there are 20 questions in this section and I recommend that you try them yourself before looking at these solutions. So let's get into it. Question 1 says that a cyclist is travelling along a straight road. The graph shows how the velocity of the cyclist varies with time. So we've got velocity on the y-axis against time on the x-axis. The kinetic energy of the cyclist is greatest at P, Q, R, S or T. Well, to answer this question, it's probably best to look at the equation for kinetic energy. So remember EK equals a half times mv squared. So we can see in this equation that if we ignore the half and the m, we've got the kinetic energy is proportional to the speed squared. So the bigger the speed or velocity, the bigger the kinetic energy. So if we look for the point here on the graph which has the biggest velocity, then that's going to tell us where the biggest kinetic energy is. So the biggest velocity on the y-axis is going to be at point P here because that is higher than, say, all the other points. So P is our final answer, which means we have A. Question 2 says that a circuit is set up as shown. So we've got a 12 volt supply, we've got ammeter A1 along here, ammeter A2 in series with this resistor, and then we've got a bulb here. So we've got this parallel circuit. The reading on ammeter A1 is 5.0 amps, and the reading on ammeter A2 is 2.0 amps. The charge passing through the lamp in 30 seconds is... Well, in order to find the charge passing through the lamp, we want to use the equation relating charge, current and time because we've got the time of 30 seconds and we want to find the charge, but that means we need to find out what the current passing through the lamp is. So if we know the current flowing through A1 is 5.0 amps and we know the current flowing through A2 is 2.0 amps, then that 5 amps passing through the supply will be split up into the 2 amps and the 3.0 amps along here. So that means we've got 3.0 amps passing through the lamp. So we can now say Q equals IT and then sub in our numbers to get 3.0 times the 30 seconds. And putting that into your calculator or just doing it in your head, 3 times 30 gives you 90 coulombs. So that gives an answer of D. Question 3 says that a lamp is connected to a constant voltage power supply. The power supply is switched on. The graph shows how the current in the lamp varies with time. So we've got current increasing until it reaches 0.05 seconds, and then you get this sort of exponentially decaying curve from 0.05 seconds until 0.45 seconds, and then it sort of levels off from 0.45 seconds onwards. It then says which row in the table shows what happens to the current and resistance of the lamp between 0.05 seconds and 0.45 seconds. So we want to find out what happens to the current and resistance. Do they increase, decrease or stay the same? Well, between the 0.05 and the 0.45 seconds, we can say that the current decreases over time. So current decreases, and we should know that if current decreases, then resistance does the opposite, because remember, resistance is simply just the opposition to current flow. So if current decreases in this time, then the resistance must increase. So we have the current decreases and resistance increases, so our answer must be A. Question 4 says that a circuit is set up as shown. So we've got this switching circuit here with the 2 resistors and a potential divider circuit with the battery. We've then got a resistor next to a transistor and a motor. And it says the purpose of the transistor is to supply energy to the circuit, decrease the voltage across R1, change electrical energy to kinetic energy, supply energy to the motor, or switch on the motor. Well, the simplest way to get the answer here is to just remember what a transistor is. And remember, a transistor is simply just a switch. It's an electronic switch. And that means the only answer here relating to a switch is E. So our answer has to be E, switch on the motor. And that's because this NPN transistor here will act to switch on the motor when the voltage across it is high enough. Question 5 says that 5 students each carry out an experiment to determine the specific heat capacity of copper. The setup used by each student is shown. So we have student 1, student 2, student 3, student 4 and student 5 setup. And it then says the student with the setup that would allow the most accurate value for the specific heat capacity of copper to be determined is student 1, 2, 3, 4 or 5. Well, if we look back at the pictures here for the setups, we want to think about what is a good setup here and what is not so good. So if we look at student 1 first of all, the fact that there is insulation in some of the other setups like student 2 and student 5 for example, suggests that they are better because they're going to keep the heat in from the immersion heater. So for student 1's setup here, the heat from the immersion heater will be lost to the surroundings through here. So that's maybe not going to give the most accurate value. For student 2, we've got this insulation and we've got the thermometer in here, so that looks pretty good. For student 3 though, we've got the immersion heater not touching the copper block. It's actually held closer to the edge of the block here and not inside the block. So that's not very good practice there. For student 4, we've not got any insulation and we've also got the thermometer outside of the copper block. So that's not going to give a very good accurate temperature. And lastly, student 5 shows the thermometer again outside of the copper block, although there is insulation. So again, the thermometer here is the thing that's letting down this setup. So that means the best setup here has to be student 2's, where we've got everything where it should be and we've got the insulation keeping the heat in. So we can say the answer is going to be student 2, which is B. Question 6 says the mass of a spacecraft is 1,200 kilograms. The spacecraft lands on the surface of a planet. The gravitational field strength on the surface of the planet is 5.0 newtons per kilogram. The spacecraft rests on 3 pads and the total area of the 3 pads is 1.5 meters squared. The pressure exerted by these pads on the surface of the planet is. Well, here we're asked for pressure and we've got a total area, so we need to use the relationship between pressure, force and area, which is P equals F over A. But before we use that, we need to find what the force is because we're not really told. But we are given some information like the mass of the spacecraft and the gravitational field strength on the surface of the planet. So we could say that the force is due to the weight of the spacecraft. So we could calculate the weight with W equals mg. So if we plug in the numbers here, we get 1,200 times the 5.0 from here and here. And if you put that into your calculator, we get 6,000 newtons. So now we have our force, we have our total area, 1.5 meters squared from the 3 pads, and we're trying to find the pressure. So to find the pressure, we use P equals F over A, substitute in the numbers to get 6,000 divided by 1.5, which gives a final answer of 4,000 pascals, or in other words, 4.0 times 10 to the 3 pascals. So this is an answer of D. Question 7 says a solid is heated from minus 15 degrees Celsius to 60 degrees Celsius. The temperature change of the solid is. Well, remember a temperature change in Kelvin is the same as a temperature change in degrees Celsius. So if this temperature change delta T is equal to this temperature minus this temperature, which is 60 minus 15, or in other words 60 plus 15, which gives us a temperature change of 75 degrees Celsius, that means that our temperature change in Kelvin is going to be identical to that. So a change of 75 degrees Celsius is going to be the same as 75 Kelvin. So that gives us an answer of B. Question 8 says that a student makes the following statements about waves. Statement 1 says that in a transverse wave, the particles vibrate parallel to the direction of travel of the wave. Statement 2 says light waves and water waves are both transverse waves. And lastly, statement 3, sine waves are longitudinal waves. Which of these statements is or are correct? Well, let's go through each statement and decide which ones are true and false. Statement 1, in a transverse wave, the particles vibrate parallel to the direction of travel of the wave. Well, that is false because remember, in a transverse wave, the particles actually vibrate perpendicular to the direction of travel of the wave. So if the wave moves side to side, then the particles move up and down. Statement 2, light waves and water waves are both transverse waves. That is true because remember, water waves move like a normal wave pattern, and light waves are all of the electromagnetic waves, which are also transverse waves. And lastly, sound waves are longitudinal waves. That is true because it's the only example we look at in National 5 Physics of longitudinal waves. So sound waves have their particles moving back and forth along the same direction of travel of the wave. So that means we have 2 and 3 are the only correct ones here, which gives an answer of E. Question 9 says that the diagram represents a wave travelling from X to Y. So we've got some distances given here. We've got from X to Y a distance of 12 metres horizontally and a full vertical height of 2.6 metres. Then says the wave travels from X to Y in a time of 0.5 seconds. Which row in the table shows the amplitude, wavelength and frequency of this wave? Well, first of all, let's get the amplitude. And remember, amplitude is defined as half the vertical height of the wave. So from the axis to the crest or the axis to the trough. So the amplitude is going to be given by 2.6, the full vertical height divided by 2, which is 1.3 meters. To get the wavelength, we need to find how many waves are in this pattern. So we're starting here, going all the way up, all the way down and back to the start for one wave. So we go 1 wave, 2 waves, 3 waves, 4 waves. So we've got 4 complete waves, but that's in 12 meters. So to get the wavelength, it's going to be 12 meters divided by the 4 waves to get the horizontal distance of one wave, which is the wavelength. So we can say that wavelength lambda is 12 divided by 4, which equals 3.0 meters. And lastly, to get the frequency, we know that there's 4 waves and the time is 0.5 seconds. So we can use the relationship between frequency, number of waves and time, which is f equals n over t. And if we sub in the numbers, we get 4 over 0.5. So that's the 4 from the number of waves that we counted and the 0.5 from the time over here. And if you do that in your head or in a calculator, 4 divided by half is the same as 8.0 hertz. So this means we have 1.3, 3.0 and 8.0, which gives an answer of C. Question 10 says that a microwave signal is transmitted by a radar station. The signal is reflected from an aeroplane. The aeroplane is at a height of 30 kilometers directly above the radar station. The time between the signal being transmitted and the reflected signal being received back at the radar station is, well, we're being asked for a time here and we know a distance and we should know a speed for microwave signals. So although it doesn't explicitly say, you should be thinking that microwaves are part of the electromagnetic spectrum. They're electromagnetic waves and therefore they travel at the speed of light, 3 times 10 to the 8 meters per second. So we can use d equals vt here, the speed distance time, to get time. So rearranging that, we get t equals d over v. You could just plug in the numbers at this stage, but I've rearranged. So we can plug in the numbers now to get 30 times 10 to the 3, which is the 30 kilometers changed into meters. So remember, we need to convert from kilometers into meters and divide that by the speed of light, 3 times 10 to the 8 meters per second. And putting that into your calculator should give you an answer of 1 times 10 to the minus 4 seconds. And you'll see that that is actually one of our options B. However, we're not finished yet because notice in the question how it's talking about the signal being transmitted and reflected. So we want the overall time for the signal to be transmitted to the aeroplane and then reflected back from the aeroplane to the station. So that's going to be this time multiplied by 2. So we multiply it by 2 since the signal is being reflected. So this gives an answer of 2 times 10 to the minus 4 seconds, which gives us an answer of C. Question 11 says that a member of the electromagnetic spectrum has a shorter wavelength than visible light and a lower frequency than X-rays. This type of radiation is. Now the best way to answer this is probably just to write down the order of the members of the electromagnetic spectrum from longest wavelength to shortest wavelength. We start with radio waves and TV waves, and then microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays. And remember, this is highest wavelength or lowest frequency up here, and then we've got lowest wavelength or highest frequency down here. So the member of the EM spectrum which has a shorter wavelength than visible light is going to be either ultraviolet, X-rays or gamma rays, but a lower frequency than X-rays, that's got to be ultraviolet, which means we have B as our final answer. Question 12 says the diagram shows the path of a ray of red light as it passes from air into a glass block. So we've got air into glass, and you'll see the light comes in and bends towards the normal because it's going from a less dense material into a more dense material. Then says which row in the table shows the angle of incidence and the angle of refraction. Well, we're just asked to identify the letters here. We don't need to deal with any actual numbers. And remember the definitions of angle of incidence and angle of refraction. The angle of incidence is the angle measured between the normal and the incident ray. So that's going to be this angle Q here. And the angle of refraction is going to be the angle measured between the normal and the refracted ray, which is going to be S. So we've got Q and S, which is option A. Moving on to question 13, it says a sample of tissue is exposed to 15 micrograys of alpha radiation and 20 micrograys of gamma radiation. The total equivalent dose received by the tissue is. Well, to find the total equivalent dose, we want to do 2 separate equivalent dose calculations and then add them together. So for the alpha radiation, first of all, we have H equals dWr, our equivalent dose equation, where we take our 15 micrograys for the absorbed dose, which is 15 times 10 to the minus 6 if we get rid of the prefix micro, and multiply that by 20, which is the radiation weighting factor for alpha radiation from the datasheet, and putting that into your calculator gives an answer of 300 times 10 to the minus 6 sieverts. And this is the same as 300 microsieverts. We then need to do the same for gamma radiation, so we have H equals dWr. Again, 20 micrograys is the same as 20 times 10 to the minus 6 times 1, where 1 is the radiation weighting factor for gamma radiation from the datasheet, and that gives us 20 times 10 to the minus 6 sieverts, or if we put it back in with the prefix, 20 microsieverts. So adding these two together gives a total equivalent dose of 300 plus 20, which is 320 microsieverts. So this gives an answer of B. Now notice how I converted the prefix micro in both cases and then put it back in. You could actually just do this question without converting the prefix, and it means that you wouldn't have to put the prefix back in, as long as you assume in both that you're dealing with microsieverts and you leave microsieverts as your final answer. Question 14 says that two forces act on an object as shown. So you've got an object here with 30 newtons acting on it west and 40 newtons acting on it south, and it says the resultant force acting on the object is. So in order to find the resultant force, we've got two vectors here that we need to add together, and remember the rule for adding two vectors together is that they need to be added nose to tail. I've got my vector going down the way first of all, and I'm going to label that as A equals 40 newtons. And then I've got a vector going from nose to tail, so I've actually just moved this vector down to be along here from nose to tail, and we'll label this B equals 30 newtons. And then we need to just join these up to get our resultant vector. So I'm going to draw that down there with two arrows to show it's the resultant, and then we'll label that side C, the hypotenuse, that's the unknown side we're trying to find. Let's also label the right angle in there and the angle theta next to the starting point. Now remember, you could do this question using the scale diagram method, but I'm using the calculation method in order to use Pythagoras because I think it's a bit quicker and sometimes a bit more accurate as well. So to find the magnitude, we have c squared equals a squared plus b squared, which equals 40 squared plus 30 squared, which equals 2,500. So we get c equals the square root of that, which equals 50 newtons. To find the direction, we need to use tan theta equals opposite over adjacent, which is equal to 30, the opposite, divided by the adjacent, which is A, which is 40, so we get 30 over 40, which equals 0.75. Then to find theta, this equals inverse tan or shift tan in your calculator of 0.75, which equals 37 degrees. And in order to get this bearing, remember we define bearings with respect to north, so this would be north up here. And in order to get the bearing, we need to define it from north all the way round to the resultant vector. So that's going to be 180 round to here, and then the further 37 degrees. So our bearing is going to be 180 plus 37. So we could say that our resultant force is equal to 50 newtons at 217. So that is going to be the answer C. Question 15 says that the graph shows how the velocity v of an object varies with time t. So we've got velocity on the y-axis against time t on the x-axis, and it says the graph could represent the motion of. Now straight away you should be thinking that if the graph crosses the x-axis, then that represents a change in direction. So let's look through each of these and see which one is dealing with a change in direction. So we've got a ball falling freely downwards, a rocket accelerating upwards, a ball thrown into the air then falling back to earth, a ball falling to earth from rest then rebounding upwards again, and a car slowing to a halt then accelerating in the same direction. So the only ones here that are dealing with a change in direction would be C and D, because E, a car slowing to a halt then accelerating in the same direction, that does not involve a change in direction, and same with A and B, you've not got any change in direction there. So let's look at C and D, a ball thrown into the air then falling back to earth. That could be the graph for that, because remember, you're going to project a ball into the air with a non-zero velocity, and it's going to come to a stop or 0 meters per second when the ball reaches its highest point, and then it's going to increase in speed as it falls back down, but we show that with a change in direction going into the negative velocities here. Whereas for a ball falling to earth from rest then rebounding upwards again, notice how it starts from rests, but we're not starting from rest here, so it cannot be D. The answer has got to be C. Moving on to question 16, it says that a trolley is released from rest at point X and moves with constant acceleration on a slope as shown. So we've got points X and Y here, and we've got some light gates connected to a computer. It then says the computer displays the acceleration and average velocity of the trolley between the light gates. The trolley is now released from rest at point Y. Which row in the table shows how the acceleration and average velocity compare with the previous results obtained? So if we look back at the picture, when the trolley is released from point X, it's obviously starting at a higher point than point Y. So we could say that when the trolley is released from point Y, it's going to have travelled a smaller distance or a smaller displacement than the trolley when it's released at X, and it's going to take a smaller time to travel through the light gates. So therefore we could say the average velocity is going to be smaller or less. So the average velocity for the trolley released from Y will be less than that for the trolley when it's released from X. For the acceleration, however, it's the steepness of the slope that affects the acceleration. So if the steepness of the slope stays the same, then the acceleration of the trolley down the slope will also be the same. It doesn't matter what point the trolley is released from. So this means that we have, for the acceleration, it should be the same, so it's going to be B or E, but we said the average velocity should be less, so that means our answer is going to be E here. Question 17 says that a rocket accelerates vertically upwards from the surface of the Earth. An identical rocket accelerates vertically upwards from the surface of Mars. The engine thrust from each rocket is the same. Which row in the table shows how the weight of the rocket and the unbalanced force acting on the rocket compares on Mars and Earth? Well, let's draw a quick free body diagram to visualize what's going on here. So if we draw a rocket here just as a box, and we've got an upward force as the thrust force and the downward force as the weight, and then we need to think about the equations for weight and unbalanced force. So for weight, first of all, remember this is given by W equals mg. So if the mass of the rocket stays the same and the gravitational field strength is the only thing differing here, and remember from the data sheet, the gravitational field strength on Mars is 3.7 newtons per kilogram, whereas the gravitational field strength on Earth is 9.8 newtons per kilogram. So since the gravitational field strength G on Mars is lower than that on Earth, and the mass stays the same, then the weight on Mars must be less, so it must be D or E as our answer. And now let's look at the unbalanced force on Mars compared to the unbalanced force on the Earth. So if we think about the equation for unbalanced force, Newton's second law, F equals ma, we can see that if mass stays the same, we're just looking at how acceleration differs. And since the weight is smaller for the rocket on Mars than the rocket on Earth, then that means that since the thrust force is the same, then that means that the unbalanced force must be bigger for this one because the acceleration will be bigger for the rocket on Mars. So this means we have less and greater, which gives an answer of D. Next we have question 18, which says a satellite is in a circular orbit around the planet. A group of students make the following statements about the satellite. Statement 1 says the greater the altitude of a satellite, the shorter its orbital period. Statement 2, the satellite has a constant vertical acceleration. And statement 3, as the satellite orbits the planet, its vertical velocity increases. Which of these statements is or are correct? Well, remember we go through each statement in turn and decide which ones are true and which ones are false. So for the first one, the greater the altitude of a satellite, the shorter its orbital period. Well, that's going to be false because that's suggesting that the further away the satellite gets from the planet, the less time it's going to take to orbit the planet. But that doesn't make sense because it should be that the greater the altitude, i.e. the further away the satellite is, the more time it's going to take to orbit the planet. For statement 2, the satellite has a constant vertical acceleration. That is true because that is true of any projectile, and remember satellites are projectiles with a constant horizontal velocity and a constant vertical acceleration. And lastly, as the satellite orbits the planet, its vertical velocity increases. Well, that's going to be false because we've just said that the vertical acceleration is constant, so we can't have that the vertical velocity increases because that would suggest an acceleration that wasn't constant. So we have that it's statement 2 that is the only correct one here, which means our answer is B. Question 19 says that a heater transfers energy to boiling water at the rate of 1,130 joules every second. The maximum mass of water converted to steam in 2 minutes is... Well, notice how we've got a time of 2 minutes, which we'll need to convert into seconds. We're asked for mass, and we've got what looks like an energy in 1,130 joules, but it's an energy every second. So you should be thinking here energy per second, joules per second. That is the same as a power. So we've actually been told a power value here and a time of 2 minutes. So we can work out what the energy is first of all from E equals PT. So we have EH equals PT, where EH is our heat energy, and we can find out what the heat energy is first from this using the power and the time, and then we can sub that into our equation for specific latent heat. So we have EH equals PT. Subbing in the numbers gives 1,130 times 2 times 60, converting from minutes into seconds. So putting that into your calculator gives an answer of 135,600 joules. And then we can use the equation for specific latent heat. Because we're dealing with boiling water here, we're going to use specific latent heat of vaporization. So we have EH equals ml. You could put a wee subscript here for the L to be LV, just to remind yourself it's the vaporization table you're looking for on the datasheet. You could then put in the numbers or just rearrange for the mass. I'm just going to rearrange. So we have M equals EH over L. Substituting in the numbers, we get 135,600 divided by 22.6 times 10 to the 5, which is the specific latent heat of vaporization from the datasheet. And putting that into your calculator gives a final answer of 0.06 kilograms, but you'll see it's not an option written in that form, but we do have 6.0 times 10 to the minus 2 kilograms, which is the same. So that's the same as 6 times 10 to the minus 2 kilograms, which means our answer is B. Lastly, question 20 says that light from stars can be split into line spectra of different colours. The line spectra from 3 stars X, Y and Z are shown, along with the line spectra of the elements helium and hydrogen. Hydrogen and helium are both present in. Well, notice how we're dealing with 3 stars here, so we kind of need to look at helium and hydrogen together with each of these stars in turn. So let's look at star X first of all with hydrogen and helium. So remember, we're being asked to find which star has both helium and hydrogen. So for star X, we can see we've got these two lines from helium. We've then got this line and this line combined, which would give us these two lines for star X. We've then got one line up here for star X, which would be given by the one from helium here. And we've then got one here from the helium as well, and one here from the hydrogen. So it looks like star X has both hydrogen and helium in it. For star Y, we can see that helium, we've got these two lines and these two lines, and we've then got these two, but you'll see that this one doesn't appear in this place here. And for star Y, we've also got a line over here which doesn't appear in helium and hydrogen. So that means that both helium and hydrogen are not present in star Y. Lastly, we've got star Z. So firstly, we've got this line in Z which doesn't appear in helium and hydrogen, but remember, we just need all of these ones to fit in these spectra for it to work. So we've got these two lines here and these two lines here, so that's fine. We've got these two lines here which will be provided by this one and this one. We've then got this and this line matching up. We've then got an extra one here, but that's okay. We've then got this one and this one, which contribute this line and this line here. And then we've got some other lines in star Z, but it looks like both hydrogen and helium both fit in to star Z. So we could say here that stars X and Z only is our answer, so that is D. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video one of these, subscribe to the channel, and I'll see you in the next one. Take care.